Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about area under the curve. Basically, we're going to do an overview in this session. Then the subsequent videos, I'm going to try and break it down into smaller bits, and we'll deal with each and every one of them. Before I proceed, don't forget to subscribe, like, and comment as well. And share this video with your colleagues and your friends. And also don't forget to click the notification bell so that when I post new videos, you'll be the first person to know. All right. So when we talk about the area under the curve, it refers to the area between the curve and the x-axis, okay? Is the space, is the area between the curve and the x-axis. So this is very important for you to know. So I'm going to write it down so that you can also write it as well in your notebook. So the area under the curve refers to the area between a curve and the x-axis. Okay, so basically it's talking about is the area between the curve and the x-axis. So, and in this video series, we're going to talk about there are about 4 types or 5 types of area under the curve we're going to talk about. So the area could be, there are about 5 of them we're going to discuss. So there'll be 5 of them we're going to talk about. So the first one is when it's entirely above the x-axis. Okay, so it's entirely above the x-axis. So for example, we have a curve like this, okay? We have something like this, and this is the upper limit, and this is the lower limit, okay? And the area under the curve, remember, it is from the curve to the x-axis. So it's going to be from this curve all the way to the x-axis here. Is that making sense? Okay. So that's when the curve is entirely above the x-axis. So it's from the curve all the way to the x-axis. All right. Now, the next one, the next type we're going to talk about is when number 2, take this a bit down. All right. So number 2 is when it's entirely below the x-axis. So entirely, now in this case, the curve is below the x-axis. All right. So for the first one, all right. So the curve, so we have a curve. Now we have, so this is a curve between the upper limit is A, the lower limit is B, and we have a function of a curve. So let's call the function f of x. So it could be anything. All right. Now but for the second one now, what we have here is exactly the same thing. But the difference now is that the curve is entirely below the x-axis. Are you seeing it? So now, instead of us having that, now it's from the curve to the x-axis. Are you seeing it? So remember, it is always from the curve to the x-axis. So that means this is the upper limit, A. This is the lower limit, B. So we're looking at integration, the definite integral. The upper limit is A, lower limit is B, and we have f of x. So don't worry, I'm going to explain each and every one of this in subsequent videos, all right? But what I want to do in this video, I want to list all of them out, all right? And the next one is what we call a combination. It's a combination. So a combination of above and below the x-axis. So now in this case, it's a combination of above and below the x-axis. So we are having this, all right? But in this case, the curve is above and below the x-axis. So now we are having, you can see, this curve now crosses the x-axis at different points. So it crosses it at A, B, and what? C. Does that make sense? Or let me use another different color so that it will come out properly. So let's say it's at A, B, and what? C. So it crosses the axis at 3 points. So remember, it's always from the curve up to the what? The x-axis. From the curve up to the what? X-axis. So the area under the curve, what we're going to calculate is that how then do we now find this point? Then number 4, we're going to then find between a curve and a line, how to find the area between a curve and a line. Okay, so we're going to find area between a curve and a line. So it's going to be something like this. So we have this, all right? So we can pick any curve. Let's assume we have a curve like this. Then we have another line like this. So you can see we have a line at this point, right? And we have a curve. So you can see the curve and the line meet at this point here. So let me call the curve the point A and B. So let's call this point. It meets at this point A, and both meet at this point B. Are you seeing it? Or let me try to make it a little bit bigger so that so nobody will be confused here. So let me say you have something like this. Oh no, let me use another pen. Black pen. So let's assume we have something like this, like that. Okay. Then we have it like this. Then we have a line that joins like this. Are you seeing it? All right. So you can see the line intersects with a curve. Okay. So at this point here, let's call this point A, and this point here, let's call this point B. But what we're interested in is the area between both of them, all right? The area between both of them. So how do you find it? Or it can also be that, the area between both of them is the most classical question you're gonna have. Then the next one as well is number 5. So number 5 is now between two curves. So number 5 is between two curves. So number 5 is between two curves. So basically, it depends how you want to have the curves. So you can have one like this, then you can have another one like this. So something like that. Then from here, you can also see that both of them are meeting at a point here, A, and a point here, what? B. All right, so you can be asked to find the area between these points here. So now these are the classical 5 questions that you can be asked. It could be entirely above the x-axis, entirely below the x-axis. It could be a combination of above and below the x-axis. It could be between a curve and a line, okay? All right, it could be between a curve and a line. And also it could be between two curves that you can be given. So what will happen is that in this series, I'm going to discuss each of them and solve some examples, okay? So basically what I want to do is that I want to just give you a brief overview of what we're going to talk about in the subsequent series. Now, in calculus, the area under a curve is a visual representation. So what we do in calculus here is that it gives us a visual representation of an integral, and this can be interpreted as an accumulated amount of whatever the function is modeling. All right. So because I know some of us do write notes of what I say, so I'm going to type it out, write it now, so that just in case you're writing notes as well, you can do that. So that means in calculus, what I just said. So I said in calculus, all right. Okay, the area under the curve is a visual representation okay, of an integral. So the area under the curve is a visual representation of an integral. So it means that this can be interpreted okay, as the accumulated amounts of whatever the function is modeling. Okay, so based on this, so therefore there'll be two things we can now say. We can now say that the area under the curve is between 2 points, all right, can be found by doing the definite integral between those 2 points, okay? So there are two things to keep in mind. So if you're finding the area under the curve between 2 points, you can do it by finding definite integral between those 2 points. And to find the area under the curve of a function between a and b is to integrate f of x based on the limits of a and b, okay? So I'm going to write this now so that you can take note of that. So therefore, all right, when you're finding the area under the curve, there are two things to keep in mind. So the first thing is that the area under the curve between 2 points can be found by doing a definite integral. Between the 2 points. Now the next one also is that then to find the area under the curve, the function you have is going to be between the upper limits and the lower limits, okay? So now to find the area under the curve, okay? Let's assume we have a particular function, y is equal to f of x. It's going to be between x is equal to a and x is equal to what? B. So basically what I'm saying is that in this case, I want you to then integrate f of x. So it means that I want you to integrate y is equal to f of x between the limits a and b. So if you want to write this mathematically, so it means that you have a, b, and you have f of x. So you have to integrate f of x between a and b. So I know for some of you be wondering that, oh, Mr. Terry, there's a lot of things here. I don't really understand what you're talking about. Don't worry. What I'm going to do is that each of the subsequent videos is going to be based on each of and every one of these. So the next video I'm going to talk about the area when it's just above the x-axis. Then the next video after that, I'm going to talk about below the x-axis, and I'll keep on going until we get to between the two curves. All right. So don't worry about it. I'm just giving a brief overview about everything I'm going to talk about on that area under the curve. So the next video, I'm going to talk about when it's entirely above the x-axis and how to solve it. Is that right? So it's important that you subscribe and click the notification bell so that when I post the video, you'll be the first person to know. All right. So I'm going to see you soon. And the next video, I'm going to start with the first one when it's entirely above the x-axis. And how do you solve area under curve for that? All right. So I'll see you soon and see you in a few minutes. All right.